share my.
You can if you want. And they're all coming in.
Let me know. Well,
Yes.
you will start the session.
Yeah. And then it is recording and we have our participants coming in. Good morning, everyone. Welcome to the second day of Maryland VTI. And this is the first session of the second day. My name is Ahu Moser. I am with, as most of you know, Maryland Department of Labor, and we have our presenter this morning, Jeannie Moon. We are so excited for her being here and for the opportunity to present. I would like to give some heads up about what we have in this webinar. So we have a chat feature. You are more than welcome to put which program you're from if you want, or if you would like to introduce yourself, you are more than welcome to put it in the chat. But I would like to remind you, when you are posting something in the chat, make sure that the selection is to everyone, not to the panelists. We would like everybody to see what you post in the chat. And we also have the Q&A section. Any questions to Jeannie or to me directly, that's another option for you to be able to put in the Q&A. I see we have some responses in the chat. Good morning, everyone. What we are going to do is that before I let Jeannie take it away, as you all know, we have a very, very short poll. I am going to have the poll on the screen. Let's do the poll. Let me launch it. It is just one poll. And we would like to know, what is your role in adult education? And I am going to end the poll in maybe 2 or 3 seconds. I see that people are still responding. I think everybody has responded. I'm going to end it now and let me share the results. And here are the results. We have mostly instructors, and we do also have program administrators and instructional specialists and transition and other positions. So, and I really would like to know what other is. Maybe you could put in the chat box, so then we could see what that other position is. So if you have any questions during the webinar, please put it in the chat or the Q&A, and then I will be here supporting Jeannie. Jeannie, thank you so much. Again, please take it away.
Thank you, Hafu. All right, so I'm gonna make my slide bigger so that you can see better. Hi, my name is Jeannie. Nice to meet you all, and thank you so much for coming to my presentation. So I guess it's a little early to discuss mathematics, but don't worry, my topic today is not too serious, not too research heavy. So I hope you have a nice cup of coffee next to you and enjoy my presentation. The topic of this presentation is why it is important for adult math students to be invited to explain how they solved an algebra or pre-algebra problem. It's a long topic, but it's gonna be fun. So thank you again for joining. And if you have any questions, feel free to write your questions in the chat anytime. You don't have to wait until the end. And also, I'm going to ask you to participate by answering the questions that I occasionally post throughout the presentation. Okay, let's get started. All right, this is the disclaimer. So it basically says the content and opinions expressed in this presentation do not necessarily reflect or present the views, positions, or policies of Maryland Department of Labor. And I'm going to let you read the rest. All right. Okay, so a few more things about me. So I'm Jeannie again. So I have been working as a GED math and ESOL instructor at the adult ESOL and literacy grant program at Montgomery College. Sorry, it's a long name. So this is my 10th year. And I also work as a high school math teacher, and I've taught AP statistics, IB calculus, geometry, and algebra. On the right-hand side of the slide, you can find the topics that I have researched and presented along my career. These are all learner-centered approaches, including the UN SDG assignments. The reason why I posted these topics is because the first thing that you need to do before inviting students to talk more in your math class is to build a learning environment where students feel comfortable to speak with you or ask questions. So after today's presentation, I'm going to add today's topic to this list. Besides work, I love puppies, and my favorite ice cream flavor is Rocky Road with dark chocolate. All right, that was me, about me. All right, these are the objectives of the presentation. Fancy words, so I'm going to let you read it, but by the end of this presentation, I hope you had a chance to think about how you can allocate your class time for students so that they can talk about how they feel, how they answer the question, and so on, and design a math lesson that embraces student talk time. All right, so let's move forward. All right, this is my favorite quote from a math educator. His name is David Spiegelhalter. He's a statistician working at Cambridge. So the reason why I like this quote is because I can see his attitude towards his students and helping them. So let me read it. Even after my decades as a statistician, when asked a basic school question using probability, I have to go away, sit in silence with a pen and paper, try it a few different ways, and finally announce what I hope is the correct answer. So the attitude I see here is modesty and honesty. So I think I'm trying to do that to my students too. So I say things like, no one is perfectionist in this room. So please try to answer the questions and practice the problems without worrying too much about making mistakes. Or I say, please, if you find me making mistakes, please let me know. It's okay, because that happens, because nobody's perfect. Or I also say, I know you guys are all adults and you have a lot of responsibilities. So please find time here and there, 5 minutes here, 10 minutes there, and read lesson notes and try to practice as much as you can. I think the way I approach to my students, and by saying these, I want to create a learning environment where students feel less intimidated or threatened, or how I teach is less rigid and more flexible for students. Okay. All right, so I divided my presentation into 4 parts. First, why algebra? Why not geometry or statistics? So algebra has its unique challenges, and I'm going to explain them in a minute. I think due to the unique challenges, we should approach to our students more actively and provide more learner-centered activities for them. Second, I'm going to explain why students talk time, why talk in learning. So there can be many different ways that students can show participation or engagement in classroom, right? So they can take notes, they can draw diagrams, but why talk? Third, I'm going to share 2 very good strategies you can use to start student talk time. So by the way, I'm going to use STT, that stands for student talk time. And lastly, I'm going to show you one sample lesson plan I made for an imaginary 1-hour pre-GED math class that embraces student talk time. If you have any questions, please let me know anytime. All right, so far so good. All right, so this is an activator for you. So say one difference between algebra and arithmetic. I know it's huge, it's big, and it's weird. It's too early to discuss this, right? So I wrote down 2 simple equations for you. In the green box, 12 plus 3 equals 15. And in the purple box, x plus 3 equals 15. So find one difference. And there is no right or wrong answer. And please put that in the chat and we'll go from there. Let's have about 2 minutes. Ahu, I can't see the time on my screen, so because
Yeah, it's okay. I am here as your timekeeper. No worries. I will let you know. Right now it is 8:11 a.m.
Thank you.
Sure.
All right. So thank you, Craig. X is a variable. Thank you. Wow, a lot of answers. Okay, so Carrie, thank you guys. Algebra deals with variables. Thank you. Tracy, there is a variable in the equation on the right. Thank you. Algebra has a variable. Thank you. Kathleen, the second uses a variable. Thank you, guys. Yes, so algebra uses variables, and this is something that I want to focus on today. Thank you, guys. And okay, here. So algebra, I'm going to call it the kingdom of variables. No offense to algebra, but look at these 4, I would say, symbols, graphs. So studies show that a lot of students actually don't know how to define the word variable. So I tested this myself. One day I asked my students to define the word variable, and some of them used Google, some of them used their dictionaries. But then nobody was able to say the definition of a variable in one simple sentence. As a matter of fact, we have to divide, in order to define the word variable, we have to divide the concept into 2 areas, equation and functions. So when we teach equations, we say a variable is a missing value and you can solve for it. And we let students practice a lot to apply the inverse operations to isolate the missing variable on one side of the equation. That's how you solve for x, right? But then when we move on to functions, a linear function, for example, we say, oh, there are 2 variables, x and y, and a function explains the relationship between the 2 variables. And unless there are 2 closed ends, the straight line will extend forever, both directions, to both directions. So you can have an indefinite amount of ordered pairs of x comma y. Then students may say, wait a minute, you said a variable is a missing value, but now you're saying x can be an open-ended concept. Yeah, so I understand if you say, oh, still algebra is a piece of cake. Yeah, I understand, but there can be seen, these can be seen as inconsistent, abstract, and ambiguous to some students, at least in the beginning stage of learning algebra. I'm sorry if you disagree with me, and that's okay. All right, let's move forward. Okay, so relatively speaking, in geometry, they give you a ton of visuals to use. They hardly ask you a question without giving you the corresponding figure. And also the subtopics of geometry are not necessarily related. For example, let's say you're a master of finding the area and perimeter of a quadrilateral, but you're a little bit confused about using pi to get the circumference and area of a circle. But your confusion about circles cannot influence your solid knowledge on quadrilaterals. So geometry is like that, right? Okay, let's take a look at statistics. I understand statistics and probabilities can be brutally difficult, but they give you some word problems where they give how they conducted a survey or experiment, how they collected data samples, and how they analyzed the result so that they can determine the validity of the result. So you can rely on your reading skills for a while. Most importantly, for statistics, you can compute anything using mostly TI-84, Google Sheets, or Microsoft Excel. So you hardly solve anything by hand. Or they ask you to interpret graphs. All you need to do is to find the correct number and say the answer. Our best friend, algebra, on the other hand, aka the kingdom of variables, students are asked to solve quite a lot of values like y-intercept, the slope, and the missing variables by hand for a while. And if they are confused in the beginning of if they are confused with understanding how to find x in an equation, it's very likely that they will stay confused when they answer questions in a system of equations or inequalities and in functions. Because subtopics in algebra are interconnected and cumulative. So I think we can at least acknowledge that there can be a huge room for misunderstanding, misinterpretation, or confusion on students' end. Okay. Any questions? All right. So now let's talk about why talk for learning. Like I said, there can be many different ways for students to engage in learning. They can draw diagrams or they can take notes. But why talk? So for this one, I think I need my cheat sheet because there are some fancy words. So I would like to pay attention to the important role of talking in learning. We want to support students with algebra by boosting their engagement, right? But why talk in learning? According to many studies and according to well-known educational scholars, including Piaget or Vygotsky, talking with peers in class helps students organize ideas and recognize details that they didn't even know they knew. This is called metacognitive understanding process, and this helps students integrate information. Talking will also give them a chance to use the math terms like variables. I say every time students say, I'm totally lost or I don't understand, I say, please try to identify exactly where you feel confused instead of saying, I don't know everything. Because in mathematics, knowing what you don't know itself is a good practice. Having a chance to talk with someone who is studying the same topic and using the same math terms to check for your understanding is a very productive way of learning, I think. And last but not least, talking makes your math class less boring or less dry. So try asking students to talk more. All right, here's an example of a great communicative learning. So ideas shared by students can evolve collaboratively, and this is my favorite part of giving student talk time. So last week with my pre-GED math class, students, I started talking about operations of integers. So usually I start by drawing a number line, and then I use a very simple expression, -2 + 4. I mark -2 saying the first number is the starting point. And then I jump 4 times to the right saying that's the information I got from the second number. 4 is a positive number and 4 is the number of jumps I need to make. And then I mark the arrival point true and saying this is the final answer. When I do this almost every semester, at least several students are happy, saying, oh, I have never seen anything like this. I love it. No confusion. I understand. But then I deliver the words from the textbook. So it says, if the two numbers have opposite signs, you have to find the difference, ignoring the signs, and the answer will follow the sign of the bigger number. When I say this or type it on the board, a shared board, then students say, oh, I don't understand that. Last week, a student turned on her speaker and said, hey, Jeannie, this is how I understood this concept. So let's say you owe $2 to your bank. So you have negative $2 in your bank. You deposited $4. Now in your bank account, you have $2. Then several students said, oh, I like this. I understand. I love this. So starting next semester, I'm going to say this example after the number line thing. Then I'm going to show the very wordy rule given by the textbook. So I believe that embracing different perspective is always productive. Also, in this case, it started with a teacher-student conversation between me and her who shared her strategy, but it has spread to most of the students who gave us feedback. So I think it was a great example of student talk time. Any questions so far? Okay. All right, so your turn. So on a scale of 1 to 10, I'm sorry, I didn't put 0. So number 1, do you agree that algebra has its unique challenges to students if you think algebra is very easy? Number 2, do you agree that talking will help you as a learner to internalize what you're learning? So you can give 2 numbers in the chat. And if you could explain briefly why you chose those numbers, that would be wonderful. Take your time, guys. Maybe, Ahu, would you let me know if it's like 3 minutes?
Sure.
Thank you. Thank you, Tracy. 10 and 2. Oops. Thank you, Peg. Students get 10s and automatically. Oh, thank you for choosing 10. Thank you. And okay, so number 2 has less number. Okay, all right. What about number 2? Tracy. Okay, Sue, number 1, algebra has specific words that are over. Yes. So Greg for number 2, 8, like learning a language. Yes, all math subjects have unique challenges. Yes, I say this too. Mathematics itself is a language. Thank you, Juanita, 10, Kathleen, 10 and 8, Bedwi, 9 and 4, Kelly, 8 and 9, Peg, 7. All right, so I support multisensory learning, singing, writing, speaking. Me too, me too. Apply there too. Yes, I'm gonna talk about inviting students who are still practicing English. So give me a second. So thank you for bringing up that point. Nice point. Talking is good and diagrams are very helpful. Yes. And then Greg for number 2, 10. Thank you. Thank you guys. And thank you for responding to each other and having response interaction in the chat. So that's always good. So as we are, okay. Tracy, you're good, you're good. All right, so excuse me. So guys, as we are all math people, can you tell me what the average was for number 1 and number 2? And which one do you think has higher average point for 1 or number 2? I think I have a feeling that you guys supported one better, number one better. So more participants say they agree that algebra has its own unique challenges. So I'm gonna say things about students who say, or participants who say math is not my thing. So I'm gonna say things about that too. So, all right, thank you, Ahu. So thank you guys for your participation. I think more of you tend to agree that algebra has its own unique challenges. All right, very good. All right, so I understand why some of you think, I'm not sure if I want to ask students to talk in my math classrooms. And those concerns, I believe, are reasonable. So one student dominates a lot of time, it can happen. Students may choose to check out. Some students say, oh, I'm going to do something else because I'm not interested in listening to other people. I want to listen to my teacher. Excuse me. And some students are practicing English and you don't want to push them to talk. And you have this doubt, what if all this is just a waste of time? I'm very busy. I have to follow pacing. I have to give assessments. So I understand. So here are my suggestions. Facilitate a short 5 to 7 minutes, no more, small group discussion. Wait, let me go back. Before everything, before all these suggestions, it is crucial that you build, once again, the atmosphere where people feel safe and comfortable to talk. That's rule number one. And then before inviting students to speak, like explicitly to explain how they solve the problem, maybe it's a great idea to facilitate a short small group discussion to avoid this number 1 and 2. So if you do that, it's less likely that one person will dominate the whole time, or students say, oh, I'm not interested. And this is my strategy, the second bullet point. I say, so who didn't have a chance to speak yet? Please turn on your speaker and then speak. Then as our students are adult learners, they read the cue and they let other people who haven't had a chance to talk have a chance. Invite comments anytime, especially if students show constructive feedback or constructive, comments, recognize them anytime. And I also try to recall what a student said. Like, for example, this is what Sarah said last week. I'm going to apply her strategy to answer this problem or in this problem solving process. So I make sure I appreciate their comments. So here, language skills are not important in STT. So here. Non-native English speakers can feel a little more nervous to speak up. I make sure to say, I really don't criticize, or I don't even care about their grammar skills or how fancy words they use when they explain how they solve a math problem. I say, we don't need a Shakespeare, and I promise I'm not a Shakespeare. So then students laugh and they feel a little more comfortable. And I check time very carefully. I'm going to talk about how to support ELLs a little more later. And as a matter of fact, I can create a whole presentation about supporting ELLs in GED preparation class, math class. But today it's not the topic, so let me move on for now. One day, a math student said, hey, Jeannie, I make extra efforts because I have to translate all the words from the book into my native language, and then I start solving problems. So what I said, and several students said, oh, I agree with you. That's what I am facing now. I have that issues too. So, and so on. So what I said, math is not English. So you're not going to see a new vocabulary word in every new question. You will see some terms more frequently and repeatedly, and you will get used to it. That's what I say. And maybe you will think, hey, Jeannie, you're a non-native English speaker too, because you can see from my French accent. And you studied ESOL and you practiced it. You studied TESOL and you practiced TESOL for a long time. So it's going to be easy for you to help ELLs. But no, it's never easy. I never think that I know more because I have been a language learner. It's not like that. So I stay respectful and I try to listen to what my students say. So if you have any questions about this, feel free to email me. I'll be happy to answer your questions or share ideas. I'm going to share my email address later in the chat. All right, for now, let's move on. Okay, so any questions so far? I guess you guys are already writing in the chat. Thank you. Talking about math can be therapeutic to diffuse some of stress of numbers and calculations. Thank you, Laura. Thank you. I really agree with you. Okay, so now I'm going to share 2 strategies that you can use to start student talk time. First, this is called example versus non-example. So you write one correct solution and one incorrect solution to the same problem. And students can choose the correct solution and be ready to explain why through peer discussions. Other students can agree or disagree. So students can choose the level of participation, and you can change how challenging this could be. So some people say example versus non-example is too simple, but no, it's not true. You can make it very difficult. So here's an example. So I wrote 3x plus 4 equals 10 on the left and on the right. So one solution is correct, the other incorrect. So I would send my students to breakout rooms, making small groups, and then they will discuss to determine which solution is correct. And then when they come back, I can invite a few students to say why they chose the correct answer, which one is the correct answer, and why. Or they can say, oh, I'm not sure why this is correct. I know for sure that one is incorrect because this. So that's what I expect from my students. So quick check. How do you think of example versus non-example strategy, right? 2 to 3 words to describe your feelings. For example, effective and simple, or easy and clear, or something. Any adjectives that you can think of about example versus non-example strategy. Doable, but not wanting to do, or anything. So let me give you 2 minutes. So thank you, Juanita. I like this strategy. It makes students think about their thinking. Yes, I agree. And also the biggest advantage of this is that students don't have to do anything from scratch, because I already gave them the equation and the solutions. They can rely on those things. So that's why this can be one of the best strategies to use when you start giving student talk time. So we don't have to ask students too much. All right, thank you, Cassidy. I like it. It's a good review of the steps in a different format. Thank you. Greg provides familiar routine. Thank you. So this will be a great routine exercise. This one and the next strategy that I'm going to be sharing. Thank you, Greg. Tracy, we're using effective. Thank you. Thank you, Tracy. Yes, critical thinking. Yes. Thank you, Peg. And yeah, encourages participation and problem solving. Yes. Very effective and non-threatening. Yes. Okay. Thank you, guys. All right. So now I have one more strategy for you. This is called contrasting cases. So this is relatively new. And if you Google Sarah Levine, so I typed Levine right here. She wrote some articles and she participated in this podcast. So you can find what she said about contrasting cases more in detail. And I recently saw that Harvard Education School provides a course specifically about contrasting cases. So the idea is that students have 2 or more correct answers or multiple answers that are similar but different. And students can compare and find differences. Look, so Sarah Levine showed this green box on the left and asked, what color is this? And students said green. She showed this bigger box with multiple colors of green, and then she went back to the first green box and asked the same question, what color is this? Then she noticed that students started adding more words like dark green, forest green. That's the idea, guys. In mathematics, students can find different approaches that explain one concept, and they can compare and they can gain conceptual flexibility and idea. So let me find my cheat sheet because these words are very, very important, and I want to make sure that I share it with you guys. Okay, so I'm sorry. In math, we can apply contrasting cases by showing multiple ways to solve a problem and have students discuss each of the methods, determine which one is the best, and explain why. This way, students can gain procedural knowledge and flexibility rather than just listening to the teacher explaining one way of solving a problem. In math, building, I believe, procedural understanding skills is crucial because they will be able to tackle a problem from multiple angles and transfer the skills to solve more problems in across sub areas in mathematics. So I would love to try adapt contrasting cases more actively in my class in the future because this is new to me too. Any questions about contrasting cases so far? So if I don't have the answer, I'll be happy to find answer with you for you. So let me know. Okay, so this, yes, for ELLs, this is very, very, very useful because they have options to choose, and they can use their background knowledge to the one they choose. I totally agree. Yes. Thank you, Peg. All right, so this is an example of contrasting cases that I made. One equation again, and in this case, unlike example versus non-example, the solutions are both correct, and we see the same answer. But I took a slightly different approach, A from B. So what I can do is to ask students work in groups to decide which one is better or which one is easier, which one they like better, and then explain why. So here's an example that I expect to hear from a student. So this person can say, oh, our group chose B because we didn't have to apply the distributive property because some of us said it was a little confusing. Plus, by skipping that step, multiplying, each term in the parentheses, we saved time. That's what I expect from students. So I believe contrasting cases is also a very effective way for students to start talking or sharing ideas or asking questions or even identifying what they don't understand in words in mathematics classroom. Okay. All right, so your turn. So we talked about 2 strategies, right? Example, non-example, and contrasting cases. Choose one of the strategies, please, and pretending we are your students and think about how you would facilitate student talk time. So what will be your expressions So imagine you're writing a script and type the expressions you will use. So I was a little worried because I type very slowly, but I realized that some of you can type very fast. So I'm not so worried. So let me give you 5 minutes and you guys can think and choose words that you will apply. And no criticism here. There's no right or wrong answer. We are all practicing. As a matter of fact, I'm still practicing using contrasting cases myself. So 5 minutes begins now. Thank you, Ahu. Guys, if you're not sure what to do, please feel free to ask me. I'll be happy to clarify. So what I expect you to do is to choose one of the two strategies and type how you would start facilitating student talk time of your version. So you can say, for example, I'm going to start a small group session using the breakout rooms. Please compare the two strategies and find a difference, for example. Thank you, Tracy. I'm trying to use the breakdown rooms in meaningful ways, and I'm thinking I might use contrasting cases in breakout rooms. This would give the students a few minutes to decide whether they prefer case A or case B. Yes, so there would be STT in the breakout rooms, then they could come back to the main room and explain to the larger group which option they chose and why. Also, maybe take a poll as to which case was more popular. Oh, wow, that's a great idea. Okay, so I can see this being fun for the students and might bring about a lot of talking. Thank you for your ideas. It's wonderful, Tracy. So I would use a combination. See, you can type a lot more than I can. So I wrote like 2 sentences. I would use a combination of both strategies. It says, Peg, what do you notice? What do you wonder? Do you have any questions based on what's presented? Which approach fits with the way you would solve this problem and why does it fit? Wow, okay. The intent is to involve as many learners as possible within the freedom for them to think their own way. Thank you. Juanita, I would pose 2 answers to math problems and ask students to explain how the answers might have been achieved. I would then ask students to evaluate if the answers were correct. Thank you. So 2 answers to math problems. So modeling is good. So I love that you guys adapt this and in different ways. Pamela, I was asked to teach an ABE math class and was given lesson plan ideas. But after the first week, I brought examples of my brushes with math problems in real life. Double A recipe. Wow, I love this. And I asked the students how they would work through it as we solved it together. Yes. So connect mathematics with real life. Craig, I would like you to look at these 2 problems and as a group come up with the correct solution. Tell me why the problem with the wrong answer is wrong. Okay. All right. So Sue, contrasting cases can be used in other areas. In the example of the dogs, after seeing several dogs, the students can easily describe the German Shepherd in detail. Yes. Thank you. Thank you, everyone. Between I do brainstorming activity before I give an example, like can X be greater than 10? Okay, so you're gonna apply this to inequalities. All right, so Greg and provide target word bank. I want to, so I was gonna say I would give word bank that says PEMDAS. Okay, thank you, Greg. So let me go back to this. I was gonna say for this case, I would provide a word bank that says the distributive property and PEMDAS, so that students are used to get used to using those math terms to explain what they think. So thank you for the idea. All right, thank you everyone. And Kathleen, thank you. So let's move forward for now. So now you may wonder, how do I allocate class time? I'm very busy. So first, introduce a new concept, and this should be done by you, of course, and define key terms and symbols and solve sample problems, preferably some simple sample problems, and give another problem and then invite students to participate, but not on one day, but little by little over over the course of the unit. So I think that's my suggestion. So here is my sample lesson plan for an imaginary pre-GED mathematics class, and the topic is inequality, and I assume that today is the first day. So for the activator, I'm going to give a simple equation. So students will have a chance to retrieve their knowledge and skills to solve for the missing variable X, and this will build a bridge between what they already know and what they will learn. And also, if they feel confused, this will be a chance for them to study and talk to friends to practice how to solve an equation. Then I will display the symbols, because the symbol thing is huge in inequalities. So I usually draw a fish on the right, and then I highlight its mouth, and a fish will open its mouth towards the bigger bait. So on the left, you see a 2-gram piece of bait, and on the right, a little bigger. So I say, oh, the fish will choose to open its mouth toward to eat the bigger one. 2, so 2 is less than 5. I read the expression, and I know it's childish, but trust me, you will remember this. So I use this. So I spend time to define key terms and symbols because it's important. And then the students practice the symbols on example problems. For example, I write -1 and -1.5, and then I ask the students to place the symbol. All right, and then I'll solve one-step sample inequalities, like X minus 4 is greater than 5. So no double steps. And then I will show example versus non-example, because today is the first day that I discuss inequalities. I'm not going to use the contrasting cases yet. So I would like to use very simple example versus non-example, and then I'm going to ask them to choose the correct answer. Independent practice can be very similar inequalities problems so that they can practice what they learned. And then formative assessments can be quizzes, Kahoot, exit ticket, and so on. Or I can make them fill in blanks using the symbols. So this is what I wrote, example versus non-example for the first day one of inequalities. So they show different answers and students can choose which one is correct, which one is wrong. Okay. All right. So summary, we are almost done, guys. Algebra can be a nightmare. We should help students more actively. Student talk time can help deepen their understanding, gain procedural knowledge, and transfer the skills. Use the strategies, example versus non-example, and contrasting cases. All right, so exit ticket. So write one takeaway from this presentation, and it can be multiple, guys, and no right or wrong answers, please. So let's have about 2 minutes, please. Thank you. Thank you, Craig. Oh, thank you. Thank you, Aho. Thank you, Francis. Thank you, Callie. So I've used example and non-examples many times before, but haven't integrated contrasting example as much. Yeah, I think contrasting cases is pretty new. I'll have to check, but compared to other strategies that we have learned, this can be pretty new, I think. Tracy, it is a valuable learning experience for students to have them talk math instead of having the teacher talk all the time. Linda, love the example versus non-example strategy. Thank you. Had we different strategies to teaching math? Thank you. Anita, this was great. Thank you. I'm definitely going to get my students to talk and model more. Thank you. Craig, algebra is complicated. Talking about the complications can help learners. Thank you. I like the idea of modeling more students. All right. I like your visual. Thank you, Kelly. All right. So we still have time. So I'm going to share one story. Is that okay, Ahu?
Absolutely. Please.
All right. So they say every great presentation conveys inspirational stories. So here's my story. I don't have math phobia, but I used to have severe glossophobia, guys. Maybe you noticed, but I experience physical symptoms that I can't control due to fear. So I have presented several times, but last year, April, I barely finished my presentation, even though it was the biggest research, it was the fanciest research project I had. I got a fellowship. But I couldn't breathe well. So I think it was a torture for the audience members who were my colleagues and my bosses because they had to see me suffer. They couldn't do anything. It was my own battle. I was losing and I was drowning. But they were amazing because they said they focused on what I did well, which was the research. And they said what I did was amazing. So what I'm trying to say is we see students who say, I'm lost. I'm not a math person. I don't understand anything. Or even they say, I give up. So when they say that, please focus on what they did well and show kindness, patience, and listen to them, what they have to say. Then they might have the courage to think about what they can do to better next time, like I did. And maybe that's what we can do for our students. So I don't think my presentation today was perfect, but at least I don't think anyone is uncomfortable because I couldn't control my physical symptoms, right? So I would call it a success. So please, I wish you could apply and use those strategies for your math students. That's it, guys. Thank you so much.
Thank you so much, Jeannie. I learned a lot. And then I hope that our participants have learned a lot. Yes, I see a question from Robert. Yes, the PowerPoint will be shared. We are also going to put the video, the recording on our YouTube. And please, after this webinar ends, please take your time to do the session evaluation. You will see the session evaluation from Zoom pop up on your screen, because your feedback is a gift, is going to be very useful for Jeannie. So Jeannie, thank you so much, and thank you everyone. I am going to share a copy of the PowerPoint with the participants. No worries, Greg. And then everyone will receive the presentation. Thank you all for joining us.
Thank you.
Bye. It was great. Thank you so much.
Thank you, Apu.
Thank you.
I forgot sharing my email address to participants. Maybe they can find my info from.
Yeah, what I'm going to do is that we could email the participants, and then we could send them any information that you want me to share with them. No problem at all.
Right.
Bye, everyone. And then I'm going to close the webinar now, so everyone could do the evaluation. Thank you so much, Jeannie.
Thank you, Apu. Have a great day, guys.
Yeah.